Hello, this is Conra, and I wanted to talk to you about long division. So I have made a very detailed example of a long division problem. This example is in a PDF format, and I will post a link to the file in the description of this video. So here is the first step. So I'm taking this polynomial here, and I'm dividing it by this. So notice that this is called the divisor, and we put it out front here. I look at this, and for long division, it's not crucial, but it is helpful to pay attention to if there are terms that are skipped. There is no term here that has x cubed. There is no term here that has just x. And so if I put a 0x cubed and a 0x here, then it will help me from making some silly mistakes in the process. Additionally, notice that it's best if I have this in descending order and if I have this in descending order. So when you learn long division just with numbers, you learn that there is a sequence that you go through. You divide, you multiply, you subtract, you check, and you bring down. So with polynomial long division, it's the same process. So the way that I am going to approach this is that I am going to do some scratch work over here. So I am going to write the short version over here, but over here I'm going to write down the long version of what we are doing. I know that with my students, many of you are more confident when we write problems out a little bit differently than if you see the short version. And once you see the long version a couple of times, then you can decide to what extent you want to start skipping steps, as in just doing those steps in your head. And you can decide, okay, the places where I'm really going to make mistakes is here, so I'm just going to write this amount of work out. Okay, so let me go ahead and get started. So the first step, like I said, is divide. And so we take the first term out front here, and we take the first term out front here, and we divide the two. So another way that sometimes I will write this is I will take this and write it as 3x to the fourth over x. So some of you might be more comfortable getting the answer if you write it in that way. So one of the ways to think about it is that exponent is 1, and we know that when we divide powers, we subtract the exponents, and so I get 3x cubed. So we write that 3x cubed here. So the next step is going to be to multiply, and so I'm going to take my answer from my division step, and I'm going to multiply it by this divisor. So remember, distributive property. So 3x cubed times x, 3x to the fourth, 3x cubed times 2 is 6x cubed. And we write that answer down here. The next step is going to be to subtract. And so I'm taking this here. I could take the whole polynomial here, but I'm going to end up combining like terms. And so these will just get carried along for the ride anyway, because there are no like terms here to combine them with. So for now, I'm just going to worry about these two terms here. And I'm actually being a little bit lazier yet. I'm not going to write that 0x cubed here. So I'm taking this and I'm subtracting this. So notice I wrote parentheses around here. One of the things that I see students do is I see students change signs at this step in the middle of this writing. I personally prefer not to do that because I would like to go back and quickly reread all of my work and look for silly mistakes, because I make silly mistakes quite frequently. If I have separated that into two different spots, so I write the distributing step over here, or maybe even I shorthand that distributing step and write it over here, then again, I can very quickly reread this and look for any mistakes that I may have made. So anyways, that was just a little side note. So coming back up here, so since there's a minus sign, remember there's an understood 1 there, so I have -1 times 3x to the fourth, so I wrote that here. negative 1 times 6x cubed. We have negative 6x cubed. And now I am combining like terms. 3x to the fourth minus 3x to the fourth will cancel. And I am left with negative 6x cubed. So in the shorthand version, I'm going to write that negative 6x cubed here. So the next step is check. My checking step is to make sure that I no longer have an x to the fourth term. And the next step is bring down. I, for some reason, didn't write that quite yet in this example, but you'll see that I'm going to bring down that negative 5x squared. So then I repeat the process. So the first term here, negative 6x cubed, gets divided by the first term here, which is x. So I have that written here. So I end up with negative 6x squared. Put the 6x squared, the negative 6x squared up here. The next step is multiply. So the negative 6x squared that I just obtained, I will multiply by the divisor. And then I have to distribute. And I get negative 6x cubed minus 12x squared. And I write that down here. And again, personally, I like to encase that in a pair of parentheses and just put the minus sign out front there. And so when I subtract, that ends up being a positive 12x squared here. The negative 6x cubed and this positive 6x cubed cancel. I have a negative 5x squared and a positive 12x squared, so I end up with 7x squared. And I write that 7x squared there. Let's repeat the process again. So first term divided by first term, I get 7x. The 7x goes there. Next step is multiply. So I have 7x times x plus 2. I multiply those. And I know by now you're starting to get bored, but that's actually a good feeling. That means that you're understanding what's going on. I purposely picked a problem that had enough steps to it so that we could get a feel for that repetition and really see how redundant. It's just the same cycle over and over and over again. Next step is subtract. So when I take these two, I didn't bother writing that 0x. So that is going to end up being a negative 14x after I distribute. And when I combine like terms, I end up with negative 14x. No x squared term anymore. Divide step. First term by first term. Negative 14x divided by x is negative 14. Multiplication. Negative 14 times x plus 2 is negative 14x minus 28. Subtract. So I'm subtracting these two. When I distribute that minus sign, I end up with a positive 28 here. And when I combine the 3 with the 28, I have a 31. And that goes here. So I want to notice at this point that this is degree 0. There's 0 x's. So I have degree 0. This had degree 1. This was an x to the first power. And so the degree here is bigger than the degree here. That means that I am done. This is the remainder. So when I end up with something that has a smaller degree than the divisor, then that's when I stop. So this is called the quotient up here. This is the remainder down here. Sometimes we will write this a little bit differently. So if you think of taking 9 divided by 2, if you actually write that out as a division problem, your quotient is 4, your remainder is 1, but we will take that 1 and put it over 2 and say that the answer can also be written as 4 and 1/2. So 9 divided by 2, I can say that the answer is 4, remainder 1, or I can say that the answer is 4 and 1/2. Same thing here. We put the remainder over the divisor. So in some problems, you will be asked for this form of the answer, and sometimes we will write the answer this way. So I have now completed an example using long division. I'm going to go ahead and record in a separate video where I go ahead and take this and do the same exact problem using synthetic division. So I will show you that in a separate video. I hope you have found this helpful, and I will talk to you again soon.